Done. يا شباب. Tomorrow there will be no class because there is that discussion sessions for you. So we'll try to make it not this week, maybe next week or the week after. I know maybe next week also we have some exams. Our duty is what? This week we have to finish Dynamics 2. Today we finish Dynamic 1, inshallah ta'ala. So we have a lack of one complete class. So we will arrange this later. We try to find any time for you, and we will have that class. Yes. وقت البريك انا ما عندي مشكله اصلا احيانا بعطيكم اصلا الكلاس بكون نعسان وقت البريك يعني حقكم تقولوا لي والله دكتور بدنا نتغدى بدنا هذا انا ما عندي مشكله خذ اللاب طيب انا لا بفكر حاليا شوف يا شباب انا بفكر اخذ اللاب اعطيكم ساعه اضافيه في اللاب يعني عفوا انتم اخذتوا في اللاب الماضي اخذتوا اللي هو داتا اند اناليسيس صح؟
جاما ريز
اليوم بكره راح تكون عندكم اللي هو ليفرز اند فلكرم اسهل بكثير منها بتخلص سريع خلال ساعه تكونوا خالصين فممكن ناخذ الساعه الثانيه نشوف شو بنرتب Okay. If you remember, I have just a point before we start. Just something to emphasize on the kinematics too. Please, just feel it. First of all, I have 2 points I need to explain before we proceed. What are these 2 points? We studied that we have 2 motion graphs, that position time graph and velocity time graph. And we mentioned also, if we have a uniform motion, the word uniform motion has 3 meanings, or 3 clues for it. عنده 3 إشارات. It means the velocity is constant.
Okay, straight line.
Or
straight
that
line.
it's, of course, it's a speed constant straight line. It's moving actually in uniform motion. Sorry, velocity is constant, that x or a is 0, and finally xt graph is straight. Again, I will repeat this for you. So this has been the year, maybe I think a couple of years before. When I say uniform motion, you have 3 evidences. That if 3 then you just look for it. Whether the velocity is constant, so it's uniform. Whether the acceleration is 0, it's uniform. Or the xt graph is straight line, regardless whether it's horizontal or vertical. We don't care. Straight line, so it is uniform. We had this question before. I will draw for you. We have 4 graphs like these. 3 of them, it's v, 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 and the last one is x. And all of them, they give you some answers, you see? Which one is uniform?
The last one.
The last one, yes. Why it is the last one?
Because it's straight. And
Yeah.
it's xt.
This is straight. This question came, I told you last year. We don't care about VT. We care about XT only. XT position time graph. Okay? So if the position time graph is straight, so it's uniform. Okay? Allah barak fikum. Pay attention. Now I will, here, this is an idea. Also, now I will talk. This is actually, we don't care about it. Because let me say something. Here A is 0, because V is, right? Here A is not 0. And here A is not. A is constant, but it's not 0. Right?
Yeah.
We say in these 3 cases that acceleration is constant, and is not equal to 0. Now, I hope so this question is okay for you. Now we have also this question. We have 4 graphs, dt. I think this is in the post class in your kinematics, I need somebody to describe this question for me. We have these 4 graphs, all of them velocity time. This one, and this one, and this one. The first one, ask yourself, what about, I need only the acceleration. Tell me, is it positive or negative?
Positive.
Yes, because this is slope. Slope is positive. So the slope here,
Negative.
perfect. The slope here,
Positive.
صاعد لفوق، صح يا شباب? This is
Negative.
okay. That's good. Now let's talk about whether it's speeding up or slowing
Down.
Now, in this case, you have to put your own values on the graph. And if the speed increases, that means speeding up. If the speed decreases, slowing
Down.
And you have to skip the signs. You don't have to consider the sign. I will tell you what. Here, gentlemen, we start from 0. After 1 second, the speed or velocity is 5. After 2 seconds, it becomes 10. So it's
Speeding up.
Okay? Put your own numbers. Here, the speed was at 0, the speed was 50. After 1 second, it becomes
40.
After 2 seconds, suppose 30. So it's
Slowing down. Because
there's
it's
no
heading towards
relation
0.
between negative and slowing down, gentlemen. Please don't mix with these. Let's go here. Now,
It's increasing.
yeah, see, the speed now here, say it's minus 50 at 0. After a second, it becomes minus 40. Then minus, what is it?
Slowing down.
Slowing down.
So the sign doesn't matter.
Yeah. I need to say something here, Shabab. Maybe somebody say, oh, doctor, that negative 50 is less than 0. No, we're not talk about the math. We talk in physics. Negative 50 it shows only, you just say 50 in negative direction. You don't say negative 50. Because somebody will ask me, no, sir, actually the speed increasing. How is it? It goes from negative 50 to 0. 0 is bigger than negative 50. No, not this way. You got the point? واضح يا شباب الفكرة?
So
Please.
سعيد بس ليش slowing down?
This one?
Yes.
Because actually the speed, we can say the absolute value is decreasing.
Yeah.
You got the absolute value قيمة مطلقة يعني هاي شباب. Yeah, it starts from the 50, then as we go, what happened? Slowing, 40, 30, 20, 10. So since the speed is decreasing, it's slowing.
Down.
Got the point?
Yeah.
We don't care about the sign. Yes, sir.
So if we compare negative 50 to positive 50, we compare them to
Directions, all
direction,
the
only
directions. Yes,
matter.
yes.
So they're equal.
This we talk about Shabab last week. We don't have any idea, just like the math. Yeah, Shabab, in math you consider always the negative sign as it has its own, we can say, explanation. No, here we have only just direction. Yes.
So basically, when the graph is heading towards the x-axis, it's gonna slow down. But when it's going far away from the x-axis, it's gonna speed up.
I think you just follow this that
Choose your,
right. You know, sometimes Shabab, you don't know how much actually we have and options for it. I think I saw this question in your actually also in the kinematics too, in the post-class question and in the past year exam. So to put your own numbers and you can here Shabab, see, it starts from 0. After a second, it becomes negative 10. 2 seconds, negative 20. So it's what? Speeds up, right? It speeds up, but it speeds up in the negative direction. You got the point, Ishma?
Yeah.
That's what we need.
Yeah.
This is what we have this case. If you have any question regarding this, please ask me. Don't worry, I will give you some also, Ishma. We have a worksheet and we have revisions before the exam. By the way, your assignment will be the end of this week. All of you have to get an access code. Access code. If you have an old version book, you try to go to the bookstore, Shigri here. You ask him to give you. If he refuses, I'm so sorry, you have to buy the book. This is our latest update from Dr. Nazih, the head of the department. I'm so sorry, ya Shabab. he told us before, we will force the publisher to give the access code for the students. Now, maybe they have some clash, and now they agree, no, the student, they have to buy the book. So yeah, Shabab, without an access code, you'll be unable to log in the Blackboard, and you go to the physics, my lab, mastering physics platform, and you can apply for. And see, you have 4 assignments and 2 online quizzes. These actually carry about 20 marks out of 100. All of them requires an access code. So please, I'm so sorry, Ashbab. We try to see, but I think there is some problem with the publisher. You should get the book or the access code. Go to the bookstore. حاول معه. إذا أعطاكم إياها شباب ممتاز. Otherwise أنت مضطر إنك تشتري كتاب.
وين اروح؟
الشقري هذا.
الشقري؟
آه. No, that code is not necessary. It's not necessary. That code is not necessary. لا يا شباب, you just log in the Blackboard. You go to physics. There's an icon is called tools. You just press the tools. There's something called by my lab, physics my lab. You just press on it. There's an assignment. You'll find an assignment. And by the way, you have full 1 week for assignment. From Thursday 5 p.m. to next Thursday 5 p.m. Please, you have a multiple log in or log out. Anytime, if you have any question, come back to me. We solve it together. So you have 2 marks. That's definitely, you will get 2 marks completely. Okay? Don't miss any mark. Inshallah ta'ala, after 1 month, we have what we call by the first online quiz, which carries 6 marks. Online quiz, you have 24 hours. But if you log in, you have only a timer for 1 hour. The time duration هو راح يكون إن شاء الله مدته يوم كامل. بس إذا دخلت معك كم بيكون؟ ساعة. تدخل في أي وقت خلال هذا اليوم اللي يناسبك. تكون محضر نفسك، تجهز كل ربعك حواليك، وكل الريسورسز، طالع كل اللابتوبات وهذا، وتقعد عليه. هذا كويس. هذا كويس طبعا.
Multiple choice.
Yeah, all of it multiple choice. I think, but you have to solve. يعني في عندنا solve the solution. الأسايمنت يا شباب الله يبارك فيكم. Don't miss any mark. لا تستهينوا فيها. الأونلاين assignment والأونلاين quizzes 20 marks. والله your final also 20 marks. يعني طلع علي. هذولي عندك صراحة مساعدة بأي وحدة. أوكي؟ وعندكم كمان اللاب 20 marks. لاحظوا اللاب والهذا 40 marks out of 100. That's perfect. والله perfect يعني 40 علامة من 100. اللي هو اللاب 20 marks وهذا is very reachable يعني في ايديك هذولا. بصراحة اللي بيخسرهم هو صراحة مقصر. والله يبارك فيكم. حاولوا بقدر المستطاع. ترى هذه التنزيلات ما كانت زمان. أنا من 5 سنوات والله كان الفيزا نايت مير للطلاب. يحلموا بالفيزا ليل نهار وكانوا يمتحنوا من أول السنة لآخرها. كومبليت. كان أنا كنت أدرسها. يعني يمتحنوا في 13 شابتر. والله عملنا لهم مساكين الطلاب يعني صاروا يحلم بالفيزا ليل نهار. انتم الحين الحمد لله تيسرت الامور معكم كثير. فلا تخسروا علامات، ترى هاي ما كانت موجوده، كان الطالب يمتحن 100% 100%. وتعرفوا انتم الباص مارك 60 اوت اوف 100 مش 50 علامه النجاح، علامه النجاح 60. فكان لما يمتحن ما جاب 60 خلص برا. انتم الحمد لله يعني في تنزيلات عندكم كثير. تنزيلات اليوم الوطني، تنزيلات فالنتاين، تنزيلات. انا طبعا ضد هذا الشيء لكن ايش نسوي؟ يعني انا ضد هذا الشيء لكن هذا
نهاية الاسبوع يبدا
اجاكم شباب اجاكم نوتس عليه. وزي ما قلت اي حاجه بالنسبه لهذا تعال عندي انا بساعدك.
طيب ما في كود للتيتشر؟
الكود لا ما بس الان بس الكتاب. بس فقط الكتاب.
لا مش لما نجي
لا ما يحتاج. لا هو هذا الكود.
في براكتس طيب
ادخل عليه وشوف تلاقي براكتس.
حسب الحل اللي فهمته.
Okay, شباب, let's start now the lesson today.
So, doctor, I'd just like to clarify a point.
Yeah.
So the uniform motion is only for the xt graph.
Yes.
Okay.
Only, not for VT graph. Okay? طيب يا شباب while we wait for this انتبهوا معي. In the couple last weeks we talked about the kinematics. And أهلا أهلا حياك الله. Kinematics, I told you gentlemen that kinematics is a branch of physics related to description of motion. How to describe the motion. So we use a word just like time, speed, acceleration, velocity, displacement, صح? This is simple. Today we have a word, it's called dynamics. Dynamics is always related to the force and motion. So if you hear the word dynamics, you remember what? The force. We have a force now. We are not talking about the time, we are not talking about distance, displacement, we talk about the force. Okay? This is the first thing that we could say. Now, if I ask this question for all of you, what the word force physically represents for you?
Definition?
Strength.
It's strength.
Wow.
Or stretching, you mean? Yes, power. Push. Yeah, yes.
It's the power to move something in the direction.
Is the power to move something. Okay. Yes.
The acceleration you make on another object.
The acceleration you make on another object. Yes, is it?
Gravity.
Gravity is a force. It's a kind of force. Yes, gravity, but it isn't here. طيب يا شباب. Let me try just here to refresh your memory. You studied this in the high school, that the force is either push or pull. انتوا درستوا يا شباب القوة هي إما دفع وإما That's it. And let me tell you something. I will try to correct this. We talk about the force. Force is different than energy. And also force is totally different than the power. Power is different concept. We're not talking about general, we're talking physically, gentlemen. You got the point? Force here is related to the either push or pull. I will show you. Everything that we apply is either push or pull. When, for example, when you close the door, you pull it. When you open the door, you just push. When you actually hold your backs, you pull. When you kick the ball, you push. When you write in the marker on the here, you push the tip of the marker on the here on the board. Nothing there. When you punch your friend, also you push his face. صح يا شباب? We can try. So all the cases here, I'm saying it's either push or pull, and this push or pull actually will cause the motion. Will also result in the motion. Okay? So this is the simplest. Now you know that the force is measured with the unit Newton.
Yeah.
I'm not going to explain. Now let me tell you something. We have two types of forces according to how they actually act. We have the types of forces. I'm sure that this is also, you took it before. We have contact forces.
Oh yeah, and long range.
Yes. Or sometimes they be called by field or long range.
Yeah.
Let me explain this for you. Contact forces, it requires a physical contact between the two objects. When I want to simply close this, I should touch it. I'm not a magician to allow to move by itself. Okay, you should touch.
Yeah.
Right, ya shabab? There should be here a contact, is a physical contact between the objects here.
Yeah.
Now, in field, there is no actually ID. There is not necessarily to there, or there is no need to be a physical contact in this one. Just like, for example, gravity. Yes, a magnet is perfect. In gravity, when you just release the marker downward, in this position, there is no physical contact between the marker and the ground.
Yeah.
But the ground apply a force on it. صح يا شباب?
Yeah.
This is called a field force. Field force or long range force. We have also magnet.
Electricity, I think.
In case of magnets, you remember that sometimes you can use a magnet by pulling here small pieces of iron from a long range. We just make it closer, and then that piece will move to the magnet. right?
Yeah.
We use, sometimes you put a coin or an iron nail at the top of the book, and we put here a magnet below it, beneath, and we just make that iron nail move. Is that right? Many things. So magnet is a long range force. Also, we have something, electricity.
Yeah.
Electric charge forces. When you rub your hair with a pen and you make it closer to the small pieces of paper, you will
Static.
attract them.
Static force.
You're not going to touch them. You just make that pen closer to it, it will attract. صح يا شباب؟ تعجبكم هذه. So please يا شباب, this is, we have it before, that this type of forces do not require a physical contact, just like its samples, just gravity, magnet, and electricity. While the contact, all the other forces requires contact is, we can say, we call them by contact forces, okay?
Okay.
Now, this is something new now, I will tell you. Now, if I'm an object here, I am a person, I hold something in my hand. See, gentlemen. Now we have some classification. My hand, here, we will call it by the agent. This agent is the source of the force. Source or origin of the force. مصدر القوة يا شباب. And this here, we call by the object. That object simply receives the force. راح يستقبل القوة. That's it. In case of the marker, when it's fall, the agent is the gravity, the earth, and this is the object. Same manner, when you kick the ball with your leg here, with your feet, now your leg is the agent and the ball is. When you punch your friend's face, your hand is the agent and his face is the object. You got the point? All of it like that, Yashra. All of it like, we have an agent and we have the object. We have the agent and we have the object. Okay. Just a beginning. كل الكمبيوترات في الأجهزة والله تعبان. We struggle with these computers. استقريتوا هنا في القاعة، هل مالكم تنزل تحت؟ خلاص. لوحدكم في الدور، صح؟ تعملوا سباقات. بس تفريط ايش اوكي. We continue now, because today is very simple things that we have. Now we talk about the types of forces. See, gentlemen, we talk about the forces, how they apply. We said that contact forces and field forces.
Yeah.
Now we say the different types of forces. We have 4 different types of forces mainly. We concern about. There are another type of force, but we don't concern about. The first type of force that we concern is the weight. Who can explain this for me? What is the weight? Just describe it, Zayd.
Weight
Yes.
is, can be changeable from
Yes.
whenever, like.
I need
different
what the
area.
word weight here. It's you can describe. Yes.
It's the الوزن.
صح. I don't know what it was.
Yes.
I need to describe.
Okay, it's
Yeah.
مقدار التأثير.
Yes,
كم
it's the
التأثير على
downward force applied by the
Gravity.
earth on any object near to the surface of the earth.
Yeah.
You just, this is my description. It's very simple. Ya Shabab, what is the weight? Simply, is the downward force. Who's actually the agent? Is the earth. Applied by the earth on any object. Why it's closer to the surface? It should be actually in the field of the earth, right?
Yeah.
Because out of the field, it will be actually, there is no force acting. خارج نطاق المجال الأرضي. So this is the idea. This is simple. That weight, gentlemen, you studied that. The weight here, it is due to the ground. We have, this is the earth, and this is the object. This is my agent, and this is the object. I need to say something regarding this. All the objects, they are simply attracted by the earth. That's why we say always that all the forces, or all the objects, sorry, they will accelerate in the same way, in the same manner. Let me explain this for you. If you have two different objects, like this marker and this eraser, you release them from the same height. Which one will reach the ground first? The marker. Let us try. Both of them. Okay? Who can justify this for me? Yes.
The air resistance.
Well, for which one of them?
Okay. تأثر عليه.
على مين فيهم؟
هنا.
طيب ليش وصلوا مع بعض؟
Same way.
لأنه كان نفس الوزن.
نفس الوزن.
لا مو بنفس الوزن.
نو. طيب
الجاذبية ترفع عليهم بنفس التساوي.
نفس التسارع، يعني هم وصلوا مع بعض. طيب. That's right till now. But the resistance we can ignore. مين عنده كمان شيء إضافي؟
The
Yes.
agent applied the same manners on the object.
So they must here fall the same way.
Same.
Yes, right. Let me tell you something, يا شباب. If you drop two different objects, different in masses, you just imagine a bird and an elephant, and you ignore air resistance. They will fall the same way. They will hit the same time. This is very simply why. It's not related to the object, it's related to the agent. Now, who pulls actually the bird? The earth. And who pulls also the elephant? The bird itself, is the earth, right? So this earth will cause that type of acceleration. That's why we say always be happy. Also, you can, by the way, you can do this here with any piece of paper, you can find it. Can you give me a piece of paper? Extra, please. See. In this piece of paper, if I here release this piece of paper and the marker, which one will reach the floor first?
Marker.
And the reason, you answer.
Air
Why?
resistance.
Air resistance. Okay, this is the same piece of paper. We just crumple it like this. It's the same piece. We are not changing the paper. Now, which one will reach first?
I think the same.
Both.
Yes.
You see. So the idea, if we ignore the air resistance, all the objects, they will accelerate to the earth in the same way. Now let's go back to that. So the idea, Shabab, here, this is the weight. We have the earth is the agent and the objects. Always, that force is always vertical and downward. Vertical and down. Okay? And we know the formula of it, that weight is equal to m times
G.
Okay, this is G for the earth is what we call by 9.8. Now, this 9.8 changes actually from one planet to
Another planet.
So if you weight is 500 Newton on Earth, it could be 150 on the moon. It could be 750 on Jupiter or Saturn, any other planet. Okay, Shabab, that's topic. Because this is keep changing from one planet to another. While this is always constant. The mass is related to the matter. That means if I say, what is my mass? Is related to actually what I have in my body, what type, we say that bones, flesh, the organs, everything. This remains always constant.
Okay.
Okay? طيب. Now this is, let's work. Now this is what we talk about at the beginning. Let me just revise with you. We say the force causes the motion. It's either push or pull. We say the force acts on an object. The force requires an agent. Force is a vector. Of course, we know that. It's either contact or long range. Now, this is the weight. I actually concerned about it. The weight is a long range force, right? Because there's no physical contact. We say an object weight vector always points vertically downward, always. And it's the symbol is W.
Right.
Now we have another type of force that we concern, which we call by tension force.
T.
Yes. By the way, you can call it T, you can call it FT, whatever it is. This is a simple.
okay.
Gentlemen, tension occurs always in ropes, حبال, wires, أسلاك, cables, etc. You can have string, threads, خيوط, كذا. Always, if you apply a force by using one ropes, cables, wires, that force we got by a tension force. Tension in English is something actually related to the mental. No, we say tension, that means it's in Arabic we say just قوة الشد on, okay? So this tension in ropes, always the force of tension is in the same direction of the rope that you use. Let me tell you something. This lead, we use this rope, so the tension will be
Okay.
okay. If we have, just like here, a light bulb connected to the ceiling, like this one, we have a light bulb like this, suppose.
Yeah.
We have here a tension through the cable.
Yeah.
This is my tension.
There's also weight.
Yes. And on the other side, we have the weight.
Weight.
Okay?
Yeah.
All of it, don't worry about this. This is the tension due to the ropes.
Yeah.
What's the direction of the rope? If you have a pulley, and then you have bakra, C, and suppose we have. Now, this is, here we have the tension here.
Yeah.
Nothing there, it's the direction of the rope that we use.
Yeah.
So this is to make it more particular, we use the word tension. It's only in ropes, wires, cables, threads, like that. في الخيوط والكابلات والأسلاك والوايرات يا شباب. واضح بارك الله
Yeah.
فيكم؟ This is here. Okay, now let's go to the next point. We have a normal force. This is sometimes confusing, but we will explain. القوة العمودية يا شباب. This is natural force. When you apply a force on the surface, you try to compress the surface. The surface actually, in turn, will apply an opposite force.
The same cause.
Yes. This force natural. Now I step on the floor. Gentlemen, my weight apply the force downward on the tires and the
Yeah.
balat. And in the turn, that tires or floor will apply the force upward.
Upward.
That's why this is natural. Now you sit in the chair. Your weight apply a force on the chair. And then the chair actually apply a force,
Opposite.
upward force. This is called the normal
Force.
I need to say something. Normal means it's normal to the surface. عمودي على السطح. So this means if you have this situation, we have an object like this. This is the normal. I'm gonna call it Fn. Okay?
Okay.
And we have on the other side, we have just only weight,
W.
W. This must be normal. That means 90 degree. Okay? Now, I'm sure that you took this before. If we have an inclined plane like this, inclined with an angle, تبوا بارك الله فيكم يا شباب. Here, this is important. What happened here? Here we have the weight is always,
Downward.
I told you, weight is always down and vertical. Vertical, رأسي يا شباب. Now, whether this is the normal now,
No, it's gonna
No.
be.
It's going down.
this is not normal to the surface. So to make it normal to the surface, we have to use this one, ya shabab. See?
Yeah.
This is my normal. Now they are different here. Because it should be perpendicular to the surface.
Yeah.
This is what we call by normal to the surface.
Yeah.
Okay? Gentlemen, this is here. This force is, we can say, is natural force. When two surfaces actually compress each other, they apply an opposite forces. Natural. Now, when you sit on the chair, you and the chair apply a force on the floor. And in turn, the floor will try to, yeah. See, gentlemen, if you sit on a chair, your weight is more than the normal force applied here or provided by the chair, you will break it. This is natural. Sometimes you sit in some weak chairs and you break it easily. Why? Because your downward weight is bigger than upward normal. Okay, Shba? Right. I'm going to give you something. Now, this is for normal. The last point, we have the friction force. قوة الاحتكاك. The friction force. Now, we are talking about that surfaces we press each other, compress each other in case of the normal. In case of the friction, when two surfaces, they slide past each other. They are moving. We have always here what we call bifriction. I want to say something. Friction is something natural. If I say here, there is a surface, there's actually, we cannot say there is a surface that is completely 100% smooth. This is true. There is no surface يا شباب completely. That means there is always a friction. الاحتكاك موجود. Even there's a friction is also here anywhere. My idea is what? The friction is coming between the small tiny parts of the surfaces. They are actually, they interact with each other when they slide past each other, and they cause what we call by the friction. Don't imagine يا شباب. Try to think of it. Your actually fingerprints in a microscope look like hills and mountains. And when you just rub your hands, that's a large amount of friction. Why? Because these tiny small things, they are in microscopic, they are very huge. They provide the friction. This is we know. Now, the friction is very good for us. Why?
Don't fall down.
Yes, because if there is no friction, you'll be unable to walk or to drive your car steadily and stable manner, right? Now I'm walking, see, I had nothing, I'm stable. Okay, if there is, suppose, that floor is slippery and binary, I will simply slip due to that.
Yeah.
Even the friction causes us to change, shoes, tires, whatever is it, is a little bit costly, but it is good for us, okay? And see, Ishbal, when you walk, listen to me, in my shoe, I push the floor backward. See how, and the floor will push me forward. Just like the car. Let me draw for you. This is the car. And this is here the driver, okay? When the driver moves forward, what happens? The wheels, they will rotate in this way. Backwards, صح يا شباب?
Yeah.
They push against this one, against the floor or the asphalt here. They push against, and as a result, it will move up. Just like in the boat. If you want to move forward, you have to push backward. صح يا شباب?
Yeah.
This is the idea. So the friction, this is we have it, and it's natural. We cannot simply hit. But in physics, sometimes, if it is hard to measure the friction, we just add one sentence, ignore the friction, or is frictionless surface. Yeah, this is in here. But sometimes we use it. That means, in another way, you can say ignore the friction. Just like when I said to you here, to your friend, ignore the air resistance. You just ignore it because it's hard to measure, not more than that. Okay, is it clear for you?
Yeah.
Right. Furthermore, before we proceed, always the friction direction will be opposite to the motion. If the motion up, the friction will be
Down.
If the motion to the right,
Left.
I have one idea here. I need here, for example, I remember this question. Suppose, gentlemen, we have a car on a ramp, just like this one. We have a car like this. This car stops completely. And this is the driver as an example. Okay? Now, the driver, when he stops the car, he just applies the handbrake. He just pull it, okay? We need to draw all the forces acting on the car. This question, I think, came last year. You can say which forces acting in the car in this way, this case. Weight.
To the dog.
Yeah, let me draw it for you. This is weight. Agree about this? Yes.
Normal force.
Barakallah feek. It's normal to the surface.
Friction.
Fraction.
By the way, friction is to the hand brake.
Yes.
In which direction?
Opposite.
Handbrake to the backward.
In this direction.
Yeah.
Allah barak. That's right. This is the force of friction.
Fraction.
Did you know why, gentlemen? See,
Because it's
we
supposed to.
we pull the handbrake. If you just release it, the car will fall down.
Yeah.
So that how it's hold it in the he apply an opposite force. This the force of friction applies by the hand brake on the wires, in the tires. This is the idea. Always just see. You actually, if we release it, we assume that the car will move downward. So the friction should be upward. That's it. Okay? طيب يا شباب. Let's see this question together. Please, you just read the questions. Very simple questions for us. Who can answer the first question here? Yes, Zaid.
Above the pushes his sled across horizontal snow to get her going, then jumps in. After she jumps in, the sled gradually slows to a halt.
Yes.
What forces act on the sled after his jump in?
This is by the
Oh,
mistake.
okay,
She's
okay.
jumped in.
Okay, since after she jumps in, so we're gonna ignore the other before for the pushing. So we're gonna focus on when she jumped
Yes.
in the sled. And then it said the sled gradually slows. So slows means that there's friction.
Okay, give me the forces here.
And so there's a surface. So there's gonna be a normal force.
Yes.
And there's gravity for sure. It's gonna be weight.
Yes.
And there's a friction force because it slows down.
So it's C.
So it's C.
You got the point? I want to say something in this regard. Sometimes, I know, maybe sometimes you are not familiar with these words, pops leader or something. There is a picture, and you can sometimes guess the meaning. Simply, pops leader is actually the athlete here who jumps inside the sled. They push the sled at a particular speed, they jump on it. Now, the sled is actually slows to a halt. توقفت. It will slow, that means there is friction. This is, and always we have a normal and weight. This by default. And this is important. Be careful. Now some people they said, okay, this is the force of pushing. Is that right?
After
No.
No. If he jumped, there's no force of pushing. I want to say something. Just imagine my hand. This mark in my hand. There's two forces act on it. It's the marker weight and my hand push up, okay? If I just here throw it up like this, imagine, in the first way, it's just leave my hand. What force is acting on the marker?
Only has.
Only gravity. Barakallah fi. Perfect. Where's my hand force?
Something.
Done. Finish, you know, because there is no physical contact. يا شباب بعض الطلاب they think, oh, if you throw the marker upward, your force will continue with the marker. No, just since the marker leaves your hand,
You're done with
you're done with it. Only the force of gravity acts on it. انتبهت عليه يا شباب؟ This is okay. Let's go to the next point. If you are standing on the floor, motionless, what are the forces that act on you? Just like me now. يلا يا شباب اللي وراهم والله سهلة. Okay, yes.
Weight, force and no force.
Yes, there is no friction. Because we assume that this is here.
Motionless.
Actually, you are motionless, you are not moving.
No,
There's static
Kinetic
friction.
friction.
Yeah, we will take it later. Now, we said that the friction is only for the moving object. Later we will classify them. راح نصنفهم صحيح كلامك. But we will classify this later. Okay, شباب. Look at this now. I need to explain this. We have here Newton's first law. Today we finish, inshallah, first law and second law. It's very simple things. Now, as you see, the driver of the car here, the car simply moves and hit that wall. That wall, when the car hit the wall, the car stops, the wall stops the car, but doesn't stop the driver. So what happened to the driver? He simply fly and this all of us, we face it with a bicycle, if your first trial. If you apply that forward brake, you flip ahead in the bike, right? This is we have it, because the brake in the bicycle, you apply the brake for the bicycle, not for your body. That's why when you apply the brake, you stop the bicycle, but you didn't stop yourself. So what happened?
Your
You
body wants to
flattened,
continue.
That's why we use what we call by the seat belts or airbags to stop the driver in this case. Now, in Newton's first law, it's a very simple law. This Newton's first law, gentlemen, talks about two cases. Object at rest remains at rest until it is acted upon by an external forces. الجسم الساكن يبقى ما لم تؤثر عليه. That's simple. That means this is a simple way. It's object at rest. Any object at rest, just like this box on the table, we have here weight and we have normal. So can I say in this case, say that net force is?
Zero.
Yes, mention 0. I need this word. Why it's 0? Because if we consider this force and these two forces are equal and opposite, they cancel each other.
Yeah.
So, gentlemen, the object at rest remains at rest until it is acted by an external force. Or, the second case, see how many options I will give you. The object move with constant
Speed.
no velocity. Or constant speed, but you should add something. Who can tell me?
Direction.
Until start by friction. The friction.
And in straight line.
Straight.
This equivalent. Or I will give you another, see ya shabab, this is sometimes confusing for you. Or moving with uniform motion. Pay attention, ya shabab. Let me tell you something. In all these three cases here, the net force will be 0. Why? In constant velocity, the acceleration is
0.
so the force is 0. In speed constant, in straight line, also the same. In uniform motion, also the velocity is constant. You got the point?
0.
Now, you can rephrase the stated line. You can say the object move with constant velocity. That's enough. Or moving with constant speed in straight,
Line.
or moving with uniform motion. All of them, they are equivalent. Now, in this case, for example, if we have a car moving at constant speed, just like this car, no? It's moving constant speed in a straight line. We can say that this is thrust force provided by the engine equal to what we call by the resistance force due to the friction and air resistance. If these two forces are equal, what about F net now?
Zero.
Barakallah feek. It
Will
is
be
0. Gentlemen, in both cases, we have total force or net force or resultant force should be
Zero.
0. That means 0. When I say resultant force 0, doesn't mean there's no forces. There's the forces, but they
They cancel
cancel
each
each
other.
other because they are vectors. انتبهوا يا شباب لما يقول لك القوة المحصلة صفر لا تعني ما يوجد قوة، يوجد قوة لكن ايش مالها؟ They cancel each other. الله يبارك فيك. Yeah, this is the idea. Now let me tell you something here. Now, you can rephrase this by yourself. We need to understand object at rest or move with constant velocity, constant speed, straight line, uniform motion, it remains as it is. That means this is F net is equal to 0 until it is acted upon by an external force. Okay, now sometimes this law we sometimes called by the law
Inertia.
of inertia. MashaAllah. Can you tell me what is this? This is inertia. But this is extra. I know. Yeah, Shabab. Inertia is actual resistance of your mass to change its state of motion. احنا بنسميها بالعربي الفصول الذاتي. Yeah, Shabab, what happened when you stop suddenly? What happened to your body?
You want to continue.
Move forward, صح?
Yeah.
When you speed up sharply, actually, also your body, صح?
Yeah.
This is the inertia. This is the inertia. Now, why we call this is the law of inertia? Here, gentlemen, here we have a kind of balance. Total force or resultant force is 0. So if you want to change this, there will be some resistance. جسمك راح يقاوم. Oh, don't stop. Let me tell you something. In case of the bicycle, when you apply the brake, the bicycle, your body simply telling, oh, I want stop. because this brake is not for me, this is for the bicycle. So what happened to your body? Move forward and you flip, right? The same way happens. If you move with a constant velocity, you are in stable manner. You are stable. If you apply suddenly the brake, your body will oppose this one. راح يقاوم أو يمانع. So what happens? It will, you'll fall or slip or whatever. This is called, يا شباب, the law of inertia. And this law of inertia depends on mass. So more massive objects, they have more inertia. That means, for example, if we have a car and truck, you know, the car can easily move faster than the truck from the traffic. لما يتحركوا من الصفر يا شباب، طلبنا منهم مين راح يسرع ويوصل لسرعة أكبر؟
Car.
طيب, if they are the same speed and we ask them to stop, which one will stop first? If they have to make a U-turn, the car will make a U-turn direct, but the truck requires a large distance to make a U-turn, صح?
Yeah.
All due to the inertia. Let me tell you a story, little bit story in that one. If I bring the chicken in this room, and I will simply ask you, can you catch that chicken? You'll be unable to catch.
Why?
Even you are faster than that chicken. All of us, we are faster.
I can stop faster.
In a straight line, if you just run straight, you are faster than chicken, but you will never catch it in this room. Or you can say rabbit or cat, whatever it. Why?
Because it doesn't move in straight line.
Just let me have.
The mass is less.
Physics. I know it's more than me. I need physics.
The mass is less, more faster than you.
Okay, she can.
More faster than you.
Yes.
She has inertia more than me.
Inertia more than you?
Less than
يا شباب, inertia, you answer. انتبهوا بعدين, بارك الله. Inertia means it's less inertia than you,
Yeah.
because it means it can change its state of motion easier than you. Its state of motion ايش؟ تغير اتجاهها يا شباب. انت مشكلتك انت زي الشاحنة وهي زي السيارة الصغيرة. هي غيرت اتجاه، انت ما عندك هذا، فايش بتضطر؟ انك تاخذ مسافة اكبر حتى تغير اتجاهك، صح؟ This is happens. رغم انه في المسافة المستقيمة انت اسرع من التشيكن، اوقات انت اسرع. ولهذا السبب تشوف احيانا في الناشونال جيوغرافيك يا شباب لما التشيتا هذا التايجر او الاسد هذا يلحق لهذا بتلاقي ديله متحرك معه عشان يعطيه فلكسبيتي. ايوه، يعطيه فلكسبيتي في تغيير اتجاه. ولاحظوا كيف يكون الديلز وهم هربانين. هذا هو الانرشيا. يعتمد على انه لهذا السبب ما بيستطيع لو مش ستريت اي واحد بيصيده، لكن لازم يمشي ايش بشكل كيرل زيجزاج لايك. طيب، ولهذا السبب يا شباب this is what we call you cannot hear. طيب, let's proceed. This is simple. This is the statement and this. Now we talk about Newton's second law. Pay attention يا شباب.
F equals MA.
Yeah. انتوا اخذتوه يا شباب second law that F is equal to MA, صح؟ That A stands for acceleration, F for force, and so we have the following. I need just here to tell you what to do. Now we have F is equal to MA. Now, if we apply a force on an object, we will cause an acceleration in the same direction of force. We can say, or another way, we can say the acceleration done by the object is direct proportional to the force. This is very simple. Direct proportion يتناسب طردي. And inverse proportion to the mass. This is inverse. What this means? It means if the force increases,
The
acceleration increases. And the mass increases,
acceleration decreases.
barakallah. Yes. And you should know the direction of the force and the acceleration are the same. If you apply a force, there will be an acceleration in the same direction of force. So I need to say something. Here and F, same direction. Please, Ishmael, you consider the acceleration and force just like selling and buying. If you sell something, there must be another person who
That's
buys it.
right.
يعني يا شباب ما بيحدث الشراء والبيع شراء لوحده، لازم يكون في بايع وشاري، صح؟
صح.
They are simultaneous, متزامنين، صح؟ This is what happened. Yes, Shabab. If there is an acceleration, there must be a force to cause that acceleration. If there is a force, there must be an acceleration. صح? This by default. Yeah, they are occur simultaneously. يحدث متزامنين. So always put in your mind. So in case, if I say the following, that V is constant now, this implies that acceleration is,
Zero.
and implies now, this is our actually addition here. What we say,
Force is zero.
Allah is it. We always keep saying, if the velocity is constant, acceleration is zero.
Yeah.
Now we add one more term, so the force is also
Zero.
okay, gentlemen. This is, please put this in your mind. Now this is simple. Let's go back to the here. I will explain that. Force causes an object to accelerate. The magnitude of acceleration is direct proportion to the force and inverse proportion to the mass. The direction of the acceleration is same as the force. Now, gentlemen, see. If this object here, this is the velocity to the right. The acceleration also to the right. So the object speeds up or slows down?
Speeds up.
Barakallahu feekum. Yeah, speeds up. So the direction force will be also to the
Right.
That's simple. طيب إذا أعطيتكم أنا, if I give you this is here, this is V to left. بس only V. I mentioned also the object slows down.
To the right. Acceleration.
So your acceleration is
Slowing down. To
to the right. صح?
Force to
And
the right.
force will be also to the. Is that clear for you? You know that this is simple. Now this law and this law, the weight are the same because the force and weight, they are both forces. Mass is the same, and this is A and G, they are both acceleration.
Yeah.
صح? This is another way of Newton's second law, not something new.
But doctor,
Yes.
But
The value?
the W1 is only for vertical, right?
Yeah, of course. This one,
Yeah.
we say that this is an example of this one. This is more generalization.
Okay.
This is actually for the object, and this is here for when we talk about the free fall object. Okay? This is particular case. طيب يا شباب, please just pay attention to me. Now we're done. If we have one object over here, this subject to one force, we will actually here there will be an acceleration result, so we can write simply F is equal to ma. Okay? Suppose we have more than one object. Sorry, one object but more than here. We have F1, we have F2.
If it's in the same direction.
So yeah, we have now
Fnet.
we need to sum them up, or instead we say F net
Yeah.
is equal to MA. F net is what? F1 plus
F2.
F2. If there's one more force here, so it should be minus
Minus
F3. You see minus in opposite direction.
No.
So if we have one force, we say FMA. If we have multiple forces, we have to use F net.
net.
F net يا شباب اللي هي what we call by resultant or the total or the net force. القوة المحصلة أو القوة النهائية أو القوة اللي هي net force. Okay? This is we have to take care of it. Yes.
If F3 and F1 is the same force, we always say for F2.
Yes.
We cancel each other.
Yeah, you can cancel. Yeah, because F net will be actually the same one. F2, yes, that's perfect. Okay, Shabab. Now, let me here. This is an example what I'm talking about now. I will read it for you, and we're done. We finished. See, Shabab, here a basketball is released from rest. كرة أسقطت. And the stiff breeze directed to the right. Breeze, that means it's actually winds, it's blowing to the right. So, in which direction the ball will move? The ball here, the basketball, weight is downward. Okay? And there's a breeze, is directed to the right, in this way. You call D, whatever is it. Breeze will nasim ya shabab, stiff breezes. So, as a result, the car will move down or to the right or to the resultant.
Resultant.
Resultant will be in which direction? صح?
Yeah.
This is the resultant. This is F net. normal. In the same way, Yashar, just like what we Fred say, if you have an object, you have here, with many forces act on it, say this is 5 Newton, this is 10 Newton, and this is, say, 20 Newton. You can replace this by one force, which is 25 Newton. This is, we call it by F net. And instead of writing 3 forces, 2 positive and 1 negative, you can write 1. Okay, instead of writing here that D force and weight, you can write what? F net. That's much easier for us. صح يا شباب?
Yes.
This we call by the net force. Okay. Let's go to the questions. This is the last 2 questions we need to answer, and we start. خلاص we done. أنا آسف أتأخر عليكم يا شباب. عارف إنه الآن بريك لكم.
لأنك دكتور نزيه بس لو غيرك ما رضينا.
بارك الله فيك. بارك الله. Okay يا شباب. We have 2 cases. We have a 40 car. Please just watch how the question. Train travels along a straight track at 40 miles per hour. We have the case 2. Skier actually speeds up as she skies downhill. متزلجة تنزل تحت هنا. Which one has, in which case, is the net force greater?
The skier.
It's the skier, but why?
It's steeper.
Because its acceleration is more than the train.
The fraction.
Now, this is
less-
at 40 miles. You know 40 miles is about 80 or 70 kilometers per hour. This is, but there's some clues لازم تنتبهوا.